Let us study chemistry together with CBSE Chemistry tips and tricks.
19.5 gram of fluoroacetic acid is dissolved in 500 gram of water. The depression in the freezing point of water is observed as 1 degree Celsius. Calculate the Van't Hoff factor and dissociation constant of fluoroacetic acid. That is a question. When you read the question, you will understand that this question is about depression in freezing point. Okay. Also, it is connected with Van't Hoff factor. So, what is the equation? Delta TF, depression in freezing point, is equal to I, which is Van't Hoff factor, KFM. M is molality. On expanding molality, this equation you can write like delta TF is equal to I into KF into WB by MB into WA on numerator into 1000. So this is the equation. Now what is WB? WB is the mass of solute. MB is the molar mass of solute. WA mass of solvent. Okay, right? Our first task is very easy to find Van't Hoff factor, right? So make the equation for Van't Hoff factor I. I is the Van't Hoff factor, right? I is equal to delta TF into MB into WA by KF into WB into 1000. Substitute the values. See what is delta TF? Depression in freezing point is observed as 1. So it is 1, right? Then now MB, molar mass of fluoroacetic acid. See, we can find it. So for carbon 12, atomic mass is 12. For hydrogen 2 into 1, 2. Then for fluorine, we know it is 19. For again carbon, right? 12 plus, see, you can see 2 oxygen. So 16 into 2. That is 32 plus you can see hydrogen. On adding all these values you will get 78. So molar mass of fluoroacetic acid is 78 into WA. WA is mass of solvent. What is that? Very clear, right? 500 by. Next is KF value for water. Better by heart the KF value. It is 1.86. 1.86. Now WB, mass of the solute, it is given in the question, right? 19.5 into 1000. On calculating, you will get 1.0753. Okay, so we finished the first part. We got the Van't Hoff factor. Next part is to find dissociation constant, right? See, if the question is regarding dissociation constant, you must know this equation. Dissociation constant is equal to C alpha square by 1 minus alpha, where C is molarity, alpha is degree of dissociation. And for dissociation, degree of dissociation is given by the equation I minus 1 by n minus 1. So for finding dissociation constant, you must know these two equations. Okay. So what is our task? First we have to find alpha, then we can find Ka, right? Ka means dissociation constant. So our first task is finding alpha. For that purpose, write the ionization step of fluoroacetic acid. CH2FCOOH undergo ionization or dissociation to give what? CH2FCOO minus plus H plus. What is alpha? Alpha is equal to I minus 1 by n minus 1. I value we already know. What is that? 1.0753 minus 1 by n. N means number of ions after dissociation. What is that? 2. 2 minus 1. On calculating, you will get 0.0753. Remember those two equations, okay? the dissociation constant is C alpha square by 1 minus alpha, and for degree of dissociation alpha, what is the equation? I minus 1 by n minus 1. So we got alpha. Now our last task is what? Finding dissociation constant. Now we have to find dissociation constant, right? Ka. What is the equation? C alpha square by 1 minus alpha. So first we have to find C, right? For finding Ka, first we have to find C. What is C? Molarity. What is the equation for molarity? Number of moles of solute by volume of solution in liter, right? Now what is number of moles? Number of moles means mass of solute by molar mass of solute. So NB is what? WB by MP into volume in liter, right? Okay, now we can check how to do this. See, C is equal to WB. WB is given in the question, right? What is that? 19.5. So 19.5, correct? By MB. MB we already find, right? What was that? 78, correct? Into volume. How to find volume of solution? We are going to approximate volume of solution as volume of solvent, that is water, by ignoring the volume of solute. Okay, that is for mathematical easiness. And how to find volume of solvent? As it is water, it is very easy. They have given the mass of water, right? And we know mass by density is volume, correct? Now what is mass? 500. And for water, what is density? 1 gram per milliliter. So 500 by 1. And what you will get? 500 ml. Okay, so what is the volume? 500 ml. And we need volume in liter, right? Not in milliliter. So 500 into 10 raised to minus 3. So what we can write? Molarity is equal to 19.5 by 78 into 500. On numerator, you will be having 10 raised to 3, right? So that is 1000. So it become, you can cut this 1500, right? And 2 and 78. So concentration molarity is what? 19.5 by 39. Now we reach our final step. See, our aim is to find a dissociation constant. Substitute everything in this equation. Ka. What is C? C is 19.5 by 39. Now, what is alpha? Alpha is 0.0753 square by 1 minus 0.0753. On calculating, you will get 3.07 into 10 raised to minus 3. Hope you understand.